If we want this thing to be continuous, the only points that we're really worried about it not being continuous are at -3, because that's where this line stops, and this cubic function takes over. So we need the cubic function to start at exactly where this line ends, at -3. And then we need the y value of this cubic when it ends at 1 has to be the same as the y value of this line when it starts at 1. So we really have three pieces here. Cx minus 5 is a line, and it's happening at less than -3. So this line could be going really pretty much anywhere, okay? And it's just going to stop at -3. Boom. So now I don't know where this line is. The line could be moved up or down. I don't know. I'm just drawing a random line. It could be anywhere, but I know it stops at -3. And then this parabola x cubed minus 2 takes over. Well, this parabola, there's nothing funny about this. We can find out, not a parabola, a cubic. We can find out exactly where this is. At -3, this thing starts at -29, which we'll pretend is right here, way down here, -29. And the graph is going to be there until we get to 1. So this graph is going to go like this, and then stop right here. And then this other line takes over. So this other line could be anywhere as well. It's just going to go off like that. For this thing to be continuous, I have to make sure that this line right here, I have to make sure that it's going to end right where this cubic starts. And then for this line here, to make sure that the function is continuous, I have to make sure that it starts right where the cubic ends. So essentially, I have to make sure that the starting point of this line here, 5x plus d, has to be where the cubic ends. And I can find out where the cubic ends by just plugging 1 into it. I have to make sure this other line, cx minus 5, has to end right where the cubic starts. And I can find out where that is by plugging -3 in, because that's where it starts at -3. So what that really boils down to for us is a couple of equations. At -3, which means this is going to be -3 times c minus 5, this thing has to equal what the cubic equals at -3, which is -29. Well, that just means, let's add 5. So 3c has got to be -24. So c has got to be 8. If c is 8, this thing will end at -29, where we need it to. Okay, so there's c. To find d, we're going to do the same exact thing. We'll do it in red. To find d, I know that at 1, 5 times 1 plus d, well, that's 5 plus d. Oh, man. I love when I do that. 5 plus d. Where are we at here? There we go. 5 plus d has got to equal what this cubic equals at 1, because that's where it stops. Well, that's 1 minus 2. That's -1. So d has got to be -6. There you go.